So today we're going to look into a point and interval estimation. So basically we already looked at last class we already know what is a point estimation, but our main focus is on interval estimation lah, right? So in any estimation problem dia kata kat sini, right, in any estimation problem we need to obtain both point estimate and interval estimate. So point estimate means that we're going to find only a single value, right? Interval estimate means that is the estimate in term of interval lah, in the interval. So there is a minimum value and maximum value, right? So that's interval estimate. So interval estimate is more intuitive, means that we cannot determine the exact value, right, of the estimate, right? But we know the point, the value that we want to estimate is within that range lah. So that is the purpose of interval estimate. So the point estimate is our best guess of the parameter, while interval estimate is give us the measure of accuracy that of a point estimate by providing an interval that contain plausible value lah. So you boleh baca dekat sini, right? We already know that if we have x bar equal to 200, so this is a point estimator, and this is our point estimate lah. Right, so this is the definition based on the last class, right? So I hope you still remember. So you can read along, read this paragraph dekat sini, note dekat sini, boleh baca dulu. Right, I will not read for you, but I just want to emphasize some point here. So dekat sini dia kata interval estimate is an interval within which we would expect to find the value of the parameter called as 1 minus alpha multiplied with 100% confidence interval. Means that we want to measure how many percent of, or how many confidence of the interval estimate, right? So we will measure based on alpha value. So alpha means the type 1 error, right? Alpha is the type 1 error, means that we are in every interval estimate that we are trying to estimate, so we are reserving some error to our calculation, right? Means that we are not 100% confident that our calculation is correct, but we try to maximize our accuracy of the interval estimation lah. So that's why we need to reserve some error to give some space for making a mistake of calculation lah, of accuracy of the estimate. Right. Usually we use 90%, 95%, 99% of the accuracy. Right. Means that if you are using 90% of the accuracy, right, accuracy means that you are reserving 10% of making a mistake of estimating the estimator lah. Kalau 95% means that we reserve 5% to make a mistake lah, not the non-accuracy estimate. Sama juga 99%. So here, if 99%, our alpha would be 1% lah. If 5%, our alpha would be 5%. If 10%, our alpha would be 10%. Right? So yang lain tolong buka webcam. So saya bagi masa dalam setengah jam sampai 8.30 saja. Right? So dekat sini boleh baca, right? A confidence level of 95% means that we are 95% confidence that mu, our mean, is within 150 and 250. right? So means that let's say your confidence interval is between 150 until 250, right? So we are confident that we have 95% confidence that our mean will falls between these two values, and we are reserving 5% of making wrong decision lah, wrong calculation, right? Okay, there are, in other word, you boleh baca dekat sini, in other word, there is only 5%, which is our alpha chance mu is not within the confidence interval, right? Boleh? Hope you understand. Okay, so now the guideline to use T or Z distribution means that if you want to do a calculation, right, of interval estimate, so basically we're going to use this is a general formula lah, x bar, which is our sample mean, plus minus. Plus minus means that we have a lower limit and upper limit lah, so that we're going to have two value here. So we're going to use the distribution, either T distribution or Z distribution, multiply with standard error. So multiply with standard error, the distribution, multiply with the standard error. So this is a general formula to calculate the interval estimate of mean. Boleh? Okay. So now we look at this one, guideline to use T or Z distribution. So guideline to use T or Z distribution based on known variance known and variance unknown lah. Let's say we have a population variance. Population variance, and let's say population variance is a sigma squared lah. Sigma squared is a population variance, and we have to choose either Z distribution or T distribution based on the sample size. When the sample size is less than 30, sorry, let's try to put like this way lah. Kita ada Z distribution and no, I think better we put like this, known and unknown. Right? So let's say the population variance is known, right? So we straight away we're going to use Z distribution lah. Macam ni senang nak nampak. So how to choose T distribution and Z distribution. So dia kata kat sini guideline, dia beritahu guideline sini satu saja. This is not covered in your manual, right? So we have small sample less than 30, we use T distribution. Large sample more than 30 or more than or equal to 30, use Z distribution. But actually they are more complicated than that. So kalau this population variance is known, so we straight away use Z distribution no matter how large or small sample size, right? So we don't care whether the sample size is small or large, right? So let's say n is more than 30, more than or equal to 30, or n is less than 30, we still use Z distribution. Right, for population variance is unknown, right? Let me put this way. And let's say we have n is less than 30 and another one is n is more than or equal to 30, right? Okay, so when n is less than 30, we're going to use T distribution, right? And when n is more than 30, right, we're going to use Z distribution, right? Okay, so this one, when the population variance is unknown, we are totally depend on sample variance. So the formula here would be This one should be x bar plus minus z alpha divided by 2 if two tail, right, is depend on the distribution lah, where if we want to find a two tail lah. So normally we want to find two tail or one tail lah. It is depend on the problem. So sigma divided by square root of n. So this is a general formula for known variance, right? For the population variance unknown, we're going to use t distribution, x bar plus minus t alpha divided by 2 with degree of freedom, which is n minus 1, and then s divided by square root of n. So this is the formula for t distribution, right? When the population variance unknown, n is less than 30. And when n is more than 30, then but we still don't know the population variance, x bar plus minus z alpha divided by 2. So alpha divided by 2 is totally depend on the problem, whether you are looking into two tail or one tail. If you are looking into one tail, so just leave it as alpha. If two tail, alpha divided by 2. So you need to divide to two tail. So multiply with s divided by square root of n. Alright, so this is the formula. And just before we go deep into the problem, z distribution is actually a standard normal distribution, right? So the distribution curve will be look like this, like look like a bell-shaped curve lah, right? So with mean equal to 0 from negative infinity to infinity. So this is z distribution. So when you have a t distribution is came from normal distribution, square root of normal distribution, right? So is a square root of normal distribution divided by chi squared. So you will have a degree of freedom lah. Right, so this is general formula for t distribution. So since it came from normal distribution, it should have a bell-shaped curve as well, and it came from chi-square distribution, so it should have degree of freedom n minus 1. So degree of freedom, right? So that's why kita akan sebut t alpha with degree of freedom, right? Okay, nanti I tunjuk dekat you how to use a t distribution and z distribution. We already looked at previous class. So now we look at the confidence interval for a mean. So the point estimate for population mean is given by the sample's mean x bar, right? The point estimate, this is a point estimate, this is what we call as point estimator lah. Benda yang sama. This is for population, this is the estimation for population, and this is given by the sample mean, right? So that's why every formula we are depending on the sample, right? So the t alpha divided by 2 is a t value within v is our degree of freedom. For one sample, the formula will be n minus 1 lah, right? So we always minus 1 for sample. If you are taking from the population, I think we no need to use t distribution, we use z distribution, so no need to minus 1. So this is the distribution curve for either z distribution or t distribution. Still apply the same curve, right? Because it's came from a standard normal distribution. So if we are measuring two tail, so this is a two tail distribution lah. Oops, Aku punya tulisan tak cantik hari ni ya. Sekejap. This is two tail distribution. Right. So two tail distribution means that we want to find the area on the left hand side and the area on the right hand side. Right. So that's why we need to divide by 2. So this is the error we reserve for the confidence interval. Right. So this is the, kalau dekat tengah ni, this is the interval that we are estimating. Right. So we are estimating 95% accurate that our mean would lies between these two range, two value lah. This is let's say this is A and B. So our mean would lies between A and B. So we have 95% confidence that this is our range, the correct one lah. So we are reserving 5% of the error, 2.5% on the right, 2.5% on the left. So this is for two tail distribution lah. Okay, boleh faham Very simple to understand, right? Ada soalan tak? Any question? Right. No, alright, good. So for one tail, so dia selalunya kita akan estimate macam ni lah. One tail kat sini. But usually we in confidence interval, we are not looking into one tail lah. So we are looking into two tail because we have range. So if one tail we are measuring from negative infinity to a certain value b, right? So it's not a very good estimate lah. So in a good estimate should have a minimum value and maximum value, right? It's a constant value. So we are using two tail distribution. So now this is confidence interval based on SPSS output. So I hope you already have your SPSS in your machine, right? You should have installed the SPSS. So for those who have my book, so you already know how to key in, right? How to enter the data, the variable. Just read my books. Right, so this is the SPSS version 28, right, the newest version. So let's say I have a data here, right, so I have a data X dekat sini, let's say I tukar lah. This is variable, apa yang dia pakai kat sini, dia pakai test 1, okay, let's say I tukar lah, test 1, oops, yes, test 1, okay. So I ada data kat sini. So to perform one sample t-test, right? To perform one sample t-test, so you need to make sure your data is a numerical data lah, and it's a scale either numeric, either interval or ratio, right? So in SPSS they only give you three scale of measurement, either scale, ordinal or nominal. So ordinal or nominal is under qualitative variable, right? It's differentiate two categorical variable. For interval and ratio, SPSS sum up into one scale, which is scale lah. The summary into scale. It doesn't matter whether it's interval or ratio, as long as it's numerical and it's conclude as scale. So now let's say to calculate one sample t-test, let's say I just go to analyze and click on compare mean and click on one sample t-test, right? Analyze, compare mean, one sample t-test. So dekat sini, let's say I reset again. So dekat sini on the left hand side is the variable available in your data set lah. Since I only have one variable, so it appear one variable dekat sini. This is a test variable on the right hand side. You just include this variable into test variable, right? And then you need to fill in the test value, right? So let's say I want to compare the data set whether it's different to test value or not. So just put 30, and I don't want to estimate effect size, and click OK. So this is the result of one sample t-test. It will give you two table, right? Table 1, table 2, right? Kalau you minta standard error, dia akan bagilah. Sepatutnya dia akan bagi 3 lah kalau you 3 kalau you minta effect size lah. Tadi I uncheck effect size, so it will give us 2 table only. So kita tengok dalam this one, right? 2 main table. First table is one sample statistics, and another one is one sample test. So this is what we call as one interval estimation for one sample mean, right? But this one is more, they have it contain more information that we require in chapter number 3, but we will revisit this topic on chapter number 4 again under hypothesis testing, right? So table number 1, it will tell us the first one is our variable. Test 1 is our variable. Kalau kita tengok dekat sini output, this is test 1, our my variable, and n is a sample size. Mean, of course, is a mean of sample, mean of the 30 sample we ask SPSS to calculate. This is a standard deviation, alright, sample standard deviation. And standard error of mean means that the standard deviation divided by square root of n, right? Standard deviation divided by square root of n, it should be equal to standard error. So this standard error will be used in our calculation, right? For when the sample size is less than 30 or more than 30. So since this is a sample size is less than 30, so we're going to use that distribution, remember? So now it gives us the second table. Second table, it provides us the t value, degree of freedom, which is n minus 1. This is our degree of freedom. So remember I talking about degree of freedom tadi kan? X bar plus minus t alpha divided by 2 n minus 1. This is the degree of freedom as divided by square root of n. And this is a mean difference. Mean difference means that we are taking the difference between the actual mean and the test value. The actual mean and the test value means 30.7917 minus 30, right? And this is the confidence interval for the difference, right? This is not a confidence interval that we are trying to find in this topic, in this chapter, right? This is the confidence interval of the difference between the actual mean for sample and the test value. So we need to, the formula will be D, the mean of difference, right, plus minus. Since this is the sample size is more than 30, so more than or equal to 30, right? Remember tadi I dah buat slide chart ni. Sample size is more than or equal to 30. The population variance unknown, right? So we're going to use Z distribution lah. So this one going to be Z alpha divided by 2 multiply with S divided by square root of n. Okay, so this is the formula. So in final exam or test, sometimes I will hide the number. You need to calculate the number lah, right? So you need to know the formula for each column. And if you want to find confidence interval for mean, right? So this one they use alpha t distribution, right? Okay, it's okay. It's okay. So you can use t distribution as well, right? Okay, use t distribution for the difference. Yeah, for the difference we need to use t distribution because this is a t value. They give us t value, kan? Okay, it's okay this one. For different, you need to use t distribution lah. T alpha divided by 2 n minus 1. And for confidence interval for mean, we use Z distribution because of n is more than or equal to 30, okay? So now let's look at example number 9. Okay, example number 9. The average zinc concentration recovered from a sample of measurement taken in 36 different locations in a river is found to be 2.6 gram per liter. So I highlight this one. This one is going to be our number of sample, right? And this is the average, right? So this is sample of population. This is mu or x bar. Mu or x bar. So this value 2.6 is taken from 36, right? This is a sample mean lah. A sample mean. So we need to find 95% confidence interval for the mean zinc concentration in the river, right? Assume that the population standard deviation is 0.3 grams. So it's already give us the population standard deviation is equal to 0.3. So means that this is the population variance is known lah. When the population variance is known, so you should use Z distribution. And no matter how large the sample or small the sample. So now, the question asks us, based on the confidence interval, can we obtain the mean zinc concentration in the river is more than 2.0 gram per milliliter? So we need to justify our answer lah. So we have n equal to, so sini dah ada jawapan, n equal to 36, sigma this population standard deviation is 0.3, alpha is 0.05. How do we know? We are based on 95% confidence interval lah. So 95% confidence interval, we are confident 95%. We are reserving 5% of making error. Right, 5% making error is alpha 0.05 lah. So 2.6 is our standard sample mean. So we just plug in the value into the formula. So Z alpha divided by 2 it should be Z 0.025, right? So 0.025, let's say kejap. Okay. Kita tengok table number 4. This is table number 3. We look into table number 4. Right. So table number 4 says that when alpha is 0.025, right, the value of u z should be equal to 1.96 lah. Tak boleh highlight kat sini. 1.96. So we just put here Z alpha 0.025 is equal to 1.96. Boleh? We need to refer to our statistical table. And then we do a calculation. So 2.6 minus 1.96 multiplied with 0.05 should be 0.098, right? So you minus lah, 2.6 minus 0.098 should be equal to 2.502. So this is the first value. The second value is 2.6 plus 0.098, right? So this is the confidence interval, right? Or this is the one way to represent a confidence interval. Another way is 2.502, right? This is mu. This is 2.698. So we are estimating for population variance lah, population means, right? So the population mean lies between 2.5 and 2.6. Okay. So this is the justification. Based on the interval, we can conclude that the mean zinc concentration in the river is more than 2 gram per liter per milliliter lah, because the mean confidence interval of the mean is more than 2.0 lah, 2.5 until 2.6. Okay. So next, let's look at example number 10. So in example number 10, so dia bagi kita kat sini, amount spent for groceries for 25 housewives were taken randomly. So we have n equal to 25, right, which is less than 30, right? But we need to read the statement sampai habis. Based on the information given, calculate the confidence interval of mean difference of the amount spent groceries of the housewife. So they give us the mean value and the standard deviation. And they give this value is for sample though. This is from a statistical table. So this is X bar, and this is your standard deviation for sample. They does not give us the value for population standard deviation or population variance. So since we don't know the population variance or population standard deviation, so we assume the population variance is unknown lah. Population variance is unknown. Population variance is unknown, so we're going to use T distribution or Z distribution. So since n is less than 30, so we use T distribution. Right? Boleh faham? So just follow the chart, kan? Senang saja you nak ikut. So since the population variance is unknown, n is less than 30, we use T distribution. So write down the formula. So formula is x bar plus minus T alpha divided by 2 n minus 1 s divided by square root of n. So very simple. So x bar is equal to 210.35 plus minus T. So since they are not stating any value for confidence interval, so in our class, dia tak bagi tahu, kalau dia tak bagi tahu the confidence, berapa persen confidence interval, our alpha tak bagi tahu, we are going to assume 95% lah. So alpha will be 0.05. Right? So T alpha divided by 2 is 0.05 divided by 2. N minus 1 is 24. S is 111.44 divided by square root of 25. Okay? So now, T alpha divided by 2 is T 0.025 with degree of freedom 24. Right? So we want to know this value. Right? So we're going to refer to as a table number 7, I think. Yes, table number 7. Table number 7. Table number 7 is a percentage point T distribution. Right? T distribution table. So before we use the table, let's read the instruction, right? The notes. The table give us the value of T alpha V. Right? Means that sama macam kita punya lah. T alpha V. And kita nak cari pun T, this is alpha, this is V. Right? Benda yang sama, okay? So alpha dia present dekat atas on the top row, and V is your degree of freedom, represent each row, the top column in each row lah. So dia kata kat sini V is your degree of freedom. Right, so this is the formula for T distribution. If you don't have this table, you can do integration lah. So alpha is the value on the right hand side, right? This is the area on the right hand side. So alpha is the area on the right hand side. This is T alpha with degree of freedom. So this is the value. Sama macam konsep macam is table number 3. Right. So our alpha for this problem is 0.025. So we're going to focus on this column. And our degree of freedom is 24. So 24 dekat sini. So it should be 2.064. 2.064. 2.064. So you masukkanlah 210.35 plus minus 2.064 multiply with 11.44 divided by square root of 25, which is 5. Right. So plug in the value into your calculator lah. 210.35. Let's say we start with a minus 1 first, right? 2.064 multiply with 11.44 divided by square root of 25 and close the bracket. It should be 205.63. So the confidence interval should be 205.63, and for the upper limit you just tukar dia punya tolak jadi tambah, right? So it should be 215.07. Right, so we can conclude that we have a 95% confidence that the population mean will lies between 205.63 and 215.07. Okay. Or we can say another word, we have 95% confidence that the mean amount spent of 25 household will lies between RM 205 and 215. Benda yang sama lah. Right. Okay. So now let's look at example number 11. Sudah? Sudah? Right. Let's look at example number 11. So we try to finish until example number 13. Right. So kita sambung next week untuk difference of two means. Example number 11. A manager of a hotel state that the mean gas bill during weekend are 700 or less. 700 or less. So dia kata dekat sini, the mean of bills will be less than 700 lah. A member of hotel accounting staff noticed that the total charge for gas bill have been increased in the recent month. So a sample of weekend gas bill was taken to test manager claim. So dia nak proof lah, claim dia betul ke tak betul kan. So the gas bill dia ambil 20 orang, 20 gas, and then the mean for gas bill is 705.80. The standard deviation is 1 in 114, and the standard error of the mean is 25. So this is very simple. So determine 95% confidence interval of mean weekend gas bill. So since the population variance are known, they are not given as the population variance, so we're going to use t distribution because the n is less than 30, right? When n is less than 30, we use t distribution. So x bar plus minus t alpha divided by 2 n minus 1 s divided by square root of n. So x bar is 705.8 plus minus t alpha divided by 2, t 0.025 and minus 1 is equal to 19. This is 114 so we don't need to use 114, tak payah calculate dah sebab dia dah bagi standard error. Standard error of the mean is s divided by square root of n. Right, so we just use the value 25.61852. Okay, so you need to find the value of t distribution to 0.025 and degree of freedom is 19, 2.093, right? 2.093. So 2.093 multiplied with 25.61852 plus minus 705.8. So use your calculator. So this one should be 705.8 minus 2.0. So I think I put like this lah. Bracket 2.093. Oops. 093 multiply with 25.61852. So this one should be 650 652 652.18 until, so kita tengok this one should be plus pula, plus 759.42, right? So this is a confidence interval for the mean weekend. Okay, now dekat sini dia tak bagi kat kita the second table. Remember inside SPSS they should give us first table and second table kan, right? So the second table is confidence interval of the different, right? So we're going to use t distribution kat sini kan, betul tak? T distribution, yes, t distribution, right? So now the claim is let's say claim is equal to 700, right? So they claim 700 kan. So now the formula will be d bar t alpha divided by 2 n minus 1 s divided by square root of n. So this is the confidence interval of mean different weekend gas bill. So our d here is d bar is equal to 705.8 minus 700 lah. So it should be equal to 5.8. Okay. So we just plug in the value into the formula. 5.8 plus minus T alpha divided by 2 is 2.093 multiplied with 25.61852. Right. Just change the value here sebab benda yang sama saja. 5.8 minus, oops, should be negative 47.82, right? And the upper limit will be 59.42, right? For this one, we can say that we have 95% confidence that the population mean would lies between RM 652.18 and RM 759.42, right? So this one we can say that we have 95% confidence that the different mean would lies between negative 47 ringgit and 59 ringgit. Okay, I think very simple. Sudah? Right. Let's look at example number 12. An experiment was conducted to measure effectiveness of the pruning method of grapes. Right. Each of 16 workers, so there are 16 workers, was assigned to prune an acre of grapes. The productivity measurement, hour per acre, for each worker is summarized below lah. So they give us the n equal to 16 and summation of x is equal to 72 and summation of x square is equal to 329.35. So we need to find the point estimate. So of the population mean is equal to x bar is equal to summation of x divided by n lah. So this is 72.5 divided by 16, right? So this one should be equal to how much? 72.5 divided by 16 should be 4.53. And the variance sigma squared equal to s square should be equal to summation of x. I think my pen is okay dah. Why still too thick? So I guna another color lah. So this is the first one. The second one is sigma squared, which is the variance, equal to s square equal to summation of x square minus summation of x, and then you square divided by n, everything divided by n minus 1, right? So this is the formula for variance, kan? So you just plug in the value into the formula, 329.35, and then this is 72.5 square divided by 16, everything divided by n minus 1. So this one should be berapa? Calculate lah. 329.35 minus 72.5 by 16 divided by 15 should be equal to 0.722, 0.722, right? 0.72. Okay, so this is the point estimate for the population mean and the point estimate for the variance equal to 0.72. So B, construct 99% confidence interval for the mean productivity of the worker. So alpha will be 0.01. So since the sample size is less than 30, so and the population variance is unknown, so we are using T distribution lah. X bar plus minus T alpha divided by 2 n minus 1 S divided by square root of n. Okay. So all my example is using T distribution kan. Nanti I cari one example yang menggunakan Z distribution. Right, later on lah. Okay. So just plug in the value into the formula. So this one should be X bar is equal to 45.3 plus minus alpha divided by 2 T 0.005 and variance is degree of freedom is equal to 16 minus 1 is equal to 15, and then the standard deviation is 0.72. So square root of 0.72 divided by square root of 16, right? Square root of 0.72 divided by square root of 16, right? So 0.05 with the 15 degree of freedom, 0.05 is here, 16 minus 1 is equal to 15 is equal to 2.947, right? 2.947 is it? Yep. So plus minus 45.3 plus minus multiply with square root of 0.72 divided by square root of 16. So just plug in the value into the formula. 45.3 minus 2 point, so later better I put like bracket lah, senang. 2.947 multiply with the square root of 0.72 square root of 16 equal to 4. Tutup kurungan, dan this is the value lah. So we have 43.67 until, so we just change the subtraction to addition, so 44.93. So we can say that we have 99% confidence that the mean population mean would lies between 43.67 and 44.93. Yes. Sorry, again? Oh yeah, I salah kan? It's okay, it's okay. 4.5 kan? Betul? You kira betul-betul dapat berapa? 4.5 lah. Right? It should be 4.5. So this one should be 4.5 lah. So this is wrong. So be careful lah. So kita tukar balik. So this one should be Wah, I kira pun salah dekat sini It is a 444. Right, so you should be very careful for 4.53. So this one should be 5.16, and the lower limit will be 3.9, 3.90, 3.91 lah. Right. So we can conclude that we have 99% confidence that the population mean would lies between 3.91 and 5.16. Right. And if you look at tadi bila you calculate kan, you boleh compare balik the logic of the confidence interval and the sample mean. Kalau dia tadi I sebut 44 something, and the population sample mean ni 4 point something, so means wrong lah. So you kena tengok balik So make sure you be careful on this, right? Okay, this is for example number 12. Now let's look at example number 13, which is our last example. Okay. A company produce 8 ounce of low-fat yogurt. 8 ounce of low-fat yogurt cup. Wanted to estimate the mean number of calories for each cup. A random sample of 10 such cup produce the following number of calories. Right. So assume that the number of calories for such cup of yogurt produced by the company has approximately normal distribution. So kalau you tengok dalam statement ni, dia did not give us the population mean kan. The population mean was not given, so this is n equal to 10, and they give us the value, right? So what is the point estimate? So mu equal to x bar equal to summation of x divided by n. So we just plug in the value. So you guna balik lah method yang I cakap tu on first chapter kan. So this one 147, 159, 153, 146, 144, 148, 163, 153, and the last one 143 and 158. So you can always recheck by using this calculator kan. Okay, so you can get the value of summation of x should be equal to 1514 divided by 10 should be equal to 151.4, right? 151.4. Okay, so then the variance which is s squared should be summation of x squared minus summation of x, and then we square divided by n, everything divided by n minus 1. So this one should be 229646, 229646 minus 1 4 1514 square divided by 10, everything divided by 9. So this one should be berapa? 47.37 lah. Okay, so this is the standard sample variance, right? And B, construct 99% confident interval that for mean number of calorie of the cup. So this one should be, since the sample size is less than 30 and the population variance is unknown, so we use x bar plus minus t alpha divided by 2 n minus 1 n minus 1 standard error lah. So x bar should be equal to 151.4, right? Plus minus alpha 0.005 n minus 1 equal to 9. This is a square root of 47.38 divided by square root of 10. So 0.05 and 9, 0.05 and 9 should be 3.25. Is it 3.25? So 3.250 multiply with square root of 47.38 divided by square root of 10 plus minus 151.4. Okay, so we just plug in the value into the formula. Should be 151.4 minus 3.250 multiply with the square root of 47.38 square root of 10. So this one should be 144.33, 144.33, and the upper limit will be 158.47. So we can say that we have 99% confidence that the population mean number of calories in the cup will lies between 144.33 and 158.47. Okay, from the confidence interval obtained, can you conclude that the mean number of calories in cup less than 100? So we can conclude that the mean number of calorie is not more than 100, which is more than 100, and it's not less than 100, which is more than 100 lah. Because the interval starting from 144 until 159, kan? Dia lebih daripada 100, right? So it's not less than 100 lah. It's more than 100. Okay? So let's focus on this question. Example number 13. So let's see. I copy this one. Ini dalam buku Alan Blumen. You boleh cari. You boleh go to library, cari Alan Blumen or Maria Triola. Any books for statistical, fundamental statistics. You boleh tengok on chapter confidence interval. Try to find the question and answer the question lah. Right. So kita buat kat tepi ni lah. So let's see. Okay. Boleh nampak kan? So, I bagi satu question lah. This is how to use another perspective. Tadi kita tengok, we already look at calculating interval estimation by using T distribution, right? So, now we're looking into Z distribution. So, dia kata dekat sini, the number of faculty of 32 randomly selected. So, we have N equal to 32. And then we use 92% confidence interval, so alpha equal to 0.08, right? Alpha is 0.08. And the population standard deviation is given as 165.1. So the point estimate, so first we need to find the point estimate lah. Estimate mu equal to x bar equal to summation of x divided by n, right? So we just plug in the value into the formula and into the calculator. Kita masukkan semua ni dulu dalam calculator. Oops. Should be 3, 1. So 211. So you try lah. You try masukkan. 211, 384, 3. So I think better I masukkan column by column. So this is 621. Okay, masuk column by column lah. 318, 471. Right, so selesai. Next one is 384, 367, 836, 638. Next one is 396, 408, 203, 425. The next one is 211, 515, 374, and 159. The next one is 224, 280, 224, 324. This is 337, 289, 121. Next is 395, 180, 412. Right, so I have 32 observation here. So you key in the data and we want to know the mean, right? Summation, I think I want to know the mean is terus dekat sini. Mean is equal to 346.25. Semua dapat number yang sama. Right, and then the standard deviation, I think we calculate for standard deviation lah. Standard deviation is S equal to square root of summation of x square minus summation of x, and then you square divided by n, everything divided by n minus 1. So we will get 165.09, 165.09, right? Ataupun kita boleh kata 10 lah. Okay. So now we want to calculate the confidence interval. Very simple. X bar plus minus Z alpha divided by 2, and the so I think for this one, since the number of sample size is more than 30, right? So the formula will be sigma over square root of n, right? Tengok balik formula yang I bagi tadi. Okay, so sigma divided by square root of n. So this one is for sample lah, right? So we don't need to use this one. We're going to use so actually benda yang sama kan. So sigma is 165.10, benda yang sama. So now you just plug in the value 346.25 plus minus z alpha divided by 2, 0.04, and this one should be 165.10 divided by square root of 32. So alpha 0.05, 0.04. So since we are looking into z distribution, look into table number 4. 0.04 is here, right? 0.04 is 1.7507. 1.7507. So you just put here 1.7507 plus minus, right, 165.10 divided by square root of 32, and this is 346.25. So you just plug in the value into the calculator to get the estimate. So this one should be 346.25 minus, and bracket here 1.7504 multiply with 165.10 divided by square root of 32. It should be equal to 295.16, and the upper limit will be 397.34, right? So we can say that we have 92% confidence that the population mean of number of faculty which lies between 295.16 and 397.34. Okay. Another way to represent this confidence interval, it should be, I think it's better for you to put in a full format lah. Jangan tinggal macam ni. You just put a 295.16, right, mu 397.34. So this is the actual presentation of the confidence interval. So yang lain-lain atas-atas yang tadi kita tengok tu semua, you need to adjust lah. You need to adjust. This one should be 144.33, right, mu 158.47, right? So you need to adjust, right? Okay. Any questions so far? So if you don't have question, then I think we stop here. Or you want me to give you more question? If you want more question, I can give to you. 7.1. This is benda yang sama lah, 7.1 and 7.2. So later on I will give you this exercise bagi kat you lah. Alright. I cannot do this. Nanti I bagi dekat you exercise. I will give you on the next session lah. I bagi nanti aku bagi ni. Right, you boleh tu buat example exercise dalam ni. Right, I think dalam buku tak ada exercise kan? Exercise tak ada dalam chapter ni. But it's okay. Nanti I akan bagi dekat you exercise to for you to do some exercise lah. You boleh practice on this chapter. Okay, ada soalan tak before we end our session? Nanti I akan bagi dalam WhatsApp ah. Alright. So if you don't have any question, then I think that's all. Thank you very much. Assalamualaikum.